So over here we have problem set 5 of the CS50 course that I took. So CS50 is Harvard's introduction to computer science. So this is the fifth project that I did in the course. So it's basically it's called Speller. What it does is it takes a text file and it iterates through all the words in the text file and see if it matches one of the words in the dictionary. And if it does, then the word exists. If the word in the text file does not match any of the words in the dictionary, then it doesn't exist and it's a misspelled word. This basically uses a hash table to make this process very efficient. So all the words in the dictionary are stored in a hash table based on a hash function that I'll later show you. But just to show you this program in action, if we wanted to run this would basically go through the surgery, all the words in the surgery.txt file, which is over here in this text directory, and it would see if any of them don't match what's in the dictionary. So if we run that, it's going to print all the misspelled words over here, and obviously these printf statements kind of make the program slower, but it doesn't really matter because for demonstration purposes it helps. So it shows us the total time it took, the time it took for each function, and the total time to load, the number of words in the text, and the number of words that were misspelled. So if we do that for another text file like federalist.txt, which is smaller, so to run faster, the same process happens. So it tells us the time and load, and the total time, the number of words in the dictionary, so on. So if I go through what this, so here, just to explain a bit of the code, here's the header file. Here is our a linked list that we have, which we're going to store the dictionary in. So it contains the actual word itself, and it contains a pointer to the next word in the list. Here we int n, it's a global integer we have. So this is the number of buckets we have. And this is the number of words that we're going to count, because part of the project was needing to count how many words were in the text file. Sorry, I don't know if I explained this yet, but number of buckets is basically how many indices we're going to have in our hash table. And our hash table is basically, at a very basic sense, is an array of linked lists. So our first function was basically loading the dictionary into our hash table. So we did this process very simply by scanning the word, and then finding which index to put that word in based on our hash function. And the hash function basically accepts our word string. So if we go over here, all this does is it just adds up all the ASCII values of each letter in the word, and it returns the total modulus n. And n, again, is the number of total buckets or indices we have. Originally, what I used was, after doing a bit of research, I found that this was supposed to be very efficient. So it multiplies the hash value, which is 401, by 16, and this 401 is supposed to reduce the number of collisions, so the number of elements at each indice in the hash table, and then it just it casts the word into an integer, and then it does modulus n. But I found that this was actually slower in the runtime than this simple hash function, so I stayed with this. Anyway, if we go back, so load basically fills in the hash table based on the hash function, and then size basically calculates how many words there are in the dictionary by going through the hash table and then adding the word number every single time. So the pointer is to the element at table I, and then it goes to the next element every single time, just like because it's a linked list, and then it returns the number of words. Originally, I calculated the size in while I was loading the hash table, but I realized that for some reason it didn't really affect the runtime. So I just kept it this way for clarity for the reader. But of course, I'd return the number of words during the actual, when I was actually loading everything. Hash, already explained it. And then over here, this just iterates through all the words in the text file and does a string comparison to see if the word matches the word in the hash table. And over here, we're just unloading everything, so we're freeing all the memory we used to actually load in the hash table. And yeah, and this works in